Hello and welcome to today's webinar. My name is Jacqueline Dorsey of Lean Frontiers and I'll serve as your host today. I'm excited to bring to you today a short webinar on Lean Information Technology facilitated by Jez Humble. Jez is the co-author of the Jolt award-winning Continuous Delivery published in Martin Fowler's Signature Series, and he has consulted for many Global 500 companies to help them achieve technical excellence and deploy a culture of experimentation and learning. This session is being recorded if you want to refer back to it later. So for now, let me turn things over to Jez.
Thank you so much, and yes, very happy to be here. I'm the author of two books to do with Lean and software development, Lean Enterprise Continuous Delivery, and my goal here is to help introduce the concepts behind the application of Lean to IT. So I'm assuming most of you here are working in IT and you've heard of Lean or played with it and you want an introduction to the foundations of it to help you implement these ideas in IT. So I'm going to start by just very briefly describing Lean and what it means. Lean fundamentally comes from the Toyota production system and the study of the Toyota production system and the application of the other industries, primarily within manufacturing, but more recently within service industries as well. So this definition you can see on the screen is from Womack and Jones, two of the most important thinkers in the Lean movement. And they say that Lean is about precisely specifying value by specific product, identifying the value stream for each product, making value flow without interruptions, and letting the customer pull value from the producer and pursue perfection. So we want to, the idea is that we identify the value streams within our organizations, and a value stream is the movement of work from a customer request to the customer receiving the results of that request. And we want to make value flow through those value streams as rapidly as possible at high quality. And what we want to pursue is relentlessly working to improve quality, reduce lead times, and reduce costs, and pursue perfection. There's a more recent definition that I'm going to also provide from Mike Rother and Leica. This is from last year, and they just made it very, very simple and straightforward. The permanent struggle to better flow value to each customer. And what they wanted to focus on is really the importance of the customer and making sure that customers are receiving value, and the fact that we're always working to get better at achieving that. So that's a very brief overview of Lean and the philosophy of Lean. I'm just going to turn briefly to the situation that we find typically within IT, and particularly the software development lifecycle, the product development lifecycle within IT. And the way this is normally done is through the mechanism of projects. We have IT projects, and even within organizations that have adopted agile software development processes, what we typically find, in my experience, is an industry standard process that I like to call water, scrum, fall. And what I'm pointing out here is that even if we're doing software development iteratively in nice iterative cycles, typically the value stream to go from an idea for a new project or product or even an enhancement to an existing one, we have to go through this quite long and painful process. Firstly, we have to actually put together a business case, then we have to get the business case approved as part of the budgeting cycle, then we have to go and design the thing that we're going to build and do often detailed requirements gathering, and then we start development. And in the development phase, we have a big set of documents that describe what we're going to build, and maybe we're using Scrum or Agile and we're developing things iteratively, but we don't actually release to users at the end of those iterations. Instead, we wait until we're dev complete, and then we go through a testing phase, and then we fix the bugs, hopefully, that we found in testing. We have to do integration, and then we have to release the software, and often we have to do quite big releases where we need to release changes to a number of different systems in one go, all at once, and that, I'm sure many of you will be familiar with, is a very painful experience for many of us. So the question is, can we do better? And the answer is yes, of course we can do better. Just to show you what the state of the art is, I like to show this slide from Amazon. This is from a couple of years ago. They're actually doing even better now. Amazon is making changes to production every 11.6 seconds. They were doing up to 1,079 deployments per hour. On average, 10,000 boxes were receiving those deployments, up to 30,000 hosts receiving those deployments. And it's important to bear in mind this is aggregated across the thousands of services that comprise Amazon's production environment. So there's a lot of services being changed here, and not every service is being changed at the same rate. Some of those services are not mission critical. Those are changed pretty often. Other services, like the services that deal with credit card payments, will change less frequently. But then this is one of the key points that they were trying to achieve, is to enable them to be fine-grained about the way they manage those different services and manage each of those services according to the risk of that service. One thing that's important to bear in mind about Amazon is that Amazon is a regulated company. They are a public company, which means they're subject to Sarbanes-Oxley. They process a very large volume of credit card payments, which means they're subject to PCI DSS, which is one of the most strict regulations in the industry. People sometimes think that Amazon is an exception, but Amazon faces the same regulation and same compliance demands as any other public company, and yet it's still able to achieve this. The other thing that's worth saying about this is that this was very hard for them. It took them 4 years to re-architect their systems to enable them to make this kind of a very rapid change. So it was a hard process for them. It required a substantial amount of investment. It's not something they achieved from being greenfield from the beginning. They actually had a pretty sophisticated but complex monolithic system that they re-architected in order to be able to achieve this goal. So the question is obviously, how can we get better? How can we move not perhaps to Amazon, because that might not be right for everyone, but how can we get better? There's a nice quote from The Economist talking about organizational agility, and what they say is the main obstacles to improve business responsiveness are slow decision-making, conflicting departmental goals and priorities, risk-averse cultures, and silo-based information. I'm sure, if you're perhaps not familiar with this, maybe you have a friend at a large organization who's experienced these kinds of problems. This should be pretty familiar. So if we're going to get better, what should we do? I want to talk about a study from Sloan that was published in MIT Sloan Management Review, which talks about 2 methods to improve the effectiveness of IT. One is to pursue better alignment with the business, and the other is to pursue more efficiency, higher levels of performance. In order to study what was the best path to achieving both high levels of alignment and high levels of performance, they surveyed a number of different companies, looking at the IT spending in those companies and the compound sales growth rate for those companies. And what they found is that if you want to move from the bottom left to the top right, there's fundamentally 2 ways to do that. You can pursue alignment first and then pursue improved performance, or you can improve performance and then pursue alignment. And what they found is that you should pursue performance first. If you pursue alignment before you improve the performance of IT, what happens is you end up spending more money and achieving lower growth. So it's very clear from this study that the way that we get better is pursuing high levels of performance rather than striving to move directly towards better alignment between IT and business needs. How do we pursue improved performance? Well, it's typically thought that we're bound by what's often called the project management iron triangle. In other words, that we have fundamental constraints like the scope we have to deliver, the schedule we have to deliver it, and the resources that we have available to us. And in the middle is quality, and if we try and squeeze the schedule or do things with less resources, then we're going to fundamentally reduce quality. And one of the most important contributions of Lean is to tell us that this is not true. It's not actually a zero-sum game. We typically think about trade-offs between throughput, going faster, and quality or stability. And it's very common to hear, well, actually, if we move faster, we're going to achieve lower quality. And fundamentally, if you take one thing away from this webinar, it's that that's not true. What Toyota did and what the Lean movement did is show that in manufacturing, it's possible to achieve higher levels of quality and lower costs and faster lead times. And the way we achieve this is by fundamentally changing the system and improving the system that we use to deliver value to our customers. So And this attitude that it's a trade-off between speed and quality is still pervasive today. Some of you will have heard of Gartner's idea of bimodal IT, that we have certain systems that we want to pursue speed and other systems where we want to pursue stability and quality. And I think that's premised on fundamentally a misunderstanding of the fact that we can actually do both. So I went out to find data about improving performance. I worked with Puppet Labs and Gene Kim and IT Revolution to investigate whether companies could actually do these things in the context of IT. And what we found was pretty interesting. We found that firms with high-performing IT were twice as likely to exceed their profitability, market share, and productivity goals. So what this means is that actually IT does matter, and high performance in IT can make a difference to your bottom line. So for years we've heard that IT doesn't matter. We have data that shows that this is not true, that IT does matter. It is important. The second thing we did is we found a statistically valid way of modeling IT performance. And the way we model IT performance in the study is we looked at 2 stability measures, which is lead time for changes going through the value stream, and then release frequency, and then 2 stability measures, time to restore service in the event of a failure or degradation of service, and then also change fail rate, which is when you push a change out to production, what percentage of the time does it either fail or does it require an emergency fix? So what we found, which was fascinating, is that the high performers did better on both of these metrics. They did better at throughput and they did better at stability, which reinforces what we know about lean practices, which is that they help you get better at both. So if you're doing it right, it's not actually a trade-off between high levels of throughput and high levels of stability and quality. You can do both. We then wanted to look at what actually, which practices actually help you with improving IT performance. And what we found is this. The highest correlation with IT performance is having your software, your code, your application configurations, and your system configurations in version control. And most important, in fact, was having your app configuration and system configuration in version control. This is a great example of a practice which helps you improve both throughput and stability. It helps you with throughput because it helps you much more rapidly create builds of your software that you can test. It means you can much more rapidly stand up test environments just using information in version control. The idea is I should be able to push a button to automatically provision a testing environment without having to manually configure it, just using information and scripts that are stored in version control. So it's pretty easy to see how that improves throughput. But the same practices improve stability. If I have a problem, an accident in production, maybe a bunch of servers go down, or there's some other failure mode in production, what's key is to be able to perform disaster recovery. How quickly can I restore service in production? If you have to manually configure the new boxes you're putting in order to recover from a disaster or restore service, if you have to manually configure those boxes, it's going to take you a non-deterministic amount of time to restore service. If you can provision those boxes purely from information and version control, you should be able to restore service in a deterministic amount of time. So this is a great example of a practice which enables higher levels of throughput and higher levels of stability. Secondly was making sure that you get failure alerts from your logging and monitoring systems, not from, say, Twitter. And then there's 2 practices that are very dear to my heart. Firstly, developers making sure they're merging their code into Trunk on a daily basis, not working in long-lived feature branches that don't get merged into Trunk or mainline until it's time to do the integration phase. And then also the last one, developers break up large features into small incremental changes. And this is one of the hardest but most important things that we require of developers, is that they learn to work in small batches. They learn to take their features or architectural changes and break them up into small incremental steps that get some of the way there, that can be pushed into Trunk, so that we can integrate and test as part of our daily work, rather than pushing that work downstream into a separate phase. And for the lean people, this is about building quality into the software rather than trying to test it later. And then the 4th bullet here is a piece around DevOps. DevOps is a movement within IT to improve the performance of our practices. When development and operations teams interact, the outcome is generally win-win rather than blame and finger pointing when things go wrong with our systems or with our deployment processes. In terms of what predicts IT performance, surprisingly, the biggest predictor of IT performance was having a peer-reviewed change approval process. And what this means is, rather than having a separate body that approves changes to production, we actually have people peer reviewing each other's changes, either through pair programming or through code review or some other mechanism other than having all changes go through a separate change advisory board. I'm going to present my hypothesis as to why this is the case. My hypothesis is that actually, I'm not saying the change approval board or having an external body to manage changes is a bad idea, but I think that that group shouldn't be in the job of manually inspecting and then approving each change. What I think they should be doing is looking at the outcomes of the change approval processes and then looking at governance around them, determining the effectiveness of those processes and working to help improve them, rather than actually inspecting every change. Because even developers who know the code base really well, and infrastructure people who understand the systems very well, they can make changes that they don't expect to break anything, but actually do break something. So what's the chance that someone in a completely different group could manually inspect those changes and understand their impact on the production environment? It's actually not a fair thing to do, to ask people who are not necessarily deeply technical and don't necessarily have a deep technical understanding of the code base to approve those changes. I remember working with a colleague of mine who'd done some work for a large manufacturer in Europe, and their change approval process involved filling in a spreadsheet with the changes with 7 tabs and sending it to a change manager who would either approve the change or not, and they would typically phone up the development manager and ask a bunch of questions, and if they liked the answers to those questions, they would approve the change. And so the developers knew the change manager didn't really understand what was written in the spreadsheet, so they would copy the previous one and make some changes and then email it through. And the change manager knew that the developers knew that they didn't know what was in the spreadsheet. And so what you have at this point is what I like to call risk management theatre. It's a performance to give the impression of better managing risk while actually just making sure that we're ticking the boxes. It doesn't actually do very much to improve risk. The other things that we care about is making sure that everything's version controlled, as we talked about before, proactive monitoring, and then something I want to talk about briefly, which I think is very important, is a high-trust organizational culture. Finally, the win-win relationship between Dev and Ops. So we modeled culture in a quantitative way by using a model from sociology that's built to actually look at safety outcomes in healthcare and aviation. So these are industries where when there are accidents, people can die, so safety is very important. And a sociologist called Ron Westrom created a typology of culture which he used to predict how organizations process information. So what he was looking at was information flow, and what he found was that high levels of information flow lead to safe cultures, to better safety outcomes, and culture is what determines the level of information flow. And I'm sure looking at this, you'll have a visceral reaction to this. You can see whether you're in a pathological power-oriented culture, whether you're in a rule-oriented culture, or whether you're in a performance-oriented culture. The two things that are particularly important here are how we deal with failure and how we deal with novelty. So in a generative organization, in a performance-oriented organization, we train people to bring us bad news. This is the idea of messengers being trained rather than shot. In power-oriented cultures, we actually shoot the messenger when they bring us bad news. And then in rule-oriented cultures, we tend to ignore bad news or find ways to kind of mitigate it without really dealing with the root cause. In high-performance organizations, we encourage people to bring us bad news and then we act on it. And then we don't blame the person who's responsible for the mistakes. Instead, we find ways to improve the system to make it better. When things that go wrong, when there are accidents, and we perform an investigation and that investigation ends up with someone having done something wrong and we fire that person, that's really problematic. The point of an investigation is to find out why that person didn't have the information they needed to make a better decision and help give them better information or better tools to be able to do the right thing. So in a performance-oriented culture, When there's an accident or a failure, we look at ways to improve the system, versus a power-oriented culture where failure leads to scapegoating and firing people. What's perhaps most fascinating about this model is the same factors that predict safety predict our ability to innovate. And this is captured in the last row, how we deal with novelty. Is it implemented? Does it lead to problems? Or is it crushed? So it's fascinating that this model predicts safety outcomes and also IT performance. The question is, of course, if you're on the left here, how do you move right and improve your culture? I really recommend listening to a podcast from This American Life, which tells the story of NUMMI. And I don't have a lot of time to go into it now, but I highly recommend it. NUMMI was a joint venture between Toyota and General Motors in the 1980s. What happened was General Motors had shut down one of their plants, their worst performing plant in North America, in Fremont, California, 30 minutes drive from my house, which was producing the worst quality cars in the whole GM portfolio in North America. Worker management relationships had completely broken down. Workers were drinking and smoking and gambling on the job. They were sabotaging the cars by putting Coke bottles in the doors so they would rattle when people opened and shut them. And so the plant was shut down. At around the same time, GM and Toyota created a joint venture so GM could learn how to build small cars in an economic way, how they could learn the Toyota production system. Toyota wants to build a new plant in America. They'd never built a plant outside Japan before. And so this joint venture was an attempt for them both to learn from each other. They decided to put the plant in Fremont at the same site as the old GM Fremont assembly plant. And then something crazy happened, which was that the Toyota leadership was convinced by the previous GM union leaders to rehire them. So Toyota ended up rehiring the same union leaders and a lot of the same staff from Fremont Assembly to run this joint venture. They all went to Japan to learn the Toyota production system, and they spent a few weeks learning it, and then they went back to America to start work at the NUMMI plant. And then within a few weeks, they were finding they were producing the same quality cars as Toyota was producing in Japan, and higher quality than any other GM plant in North America, and more cheaply too. And what this shows us is it's not the people that's the problem, it's the system that was the problem. And actually what they needed to do is improve their system of work. How did they improve their system of work? Well, again, that's a long discussion, but I just want to point to one very important thing. This is a picture of a production line in a Toyota factory in the UK. And you can see on the bottom left-hand side, there's some marks along the floor. And what this is this tells you how much space and time you've got to do your job on the production line before the car moves down to the next cell for the next job to be done. So you might imagine in this cell, the job is to put in the seats of the car. So what might happen is the car might come in at the far end of the picture into this cell. There's someone whose job it is to put in the car, to put the seat in the car, and they get some way along it as the car's moving, but they make some mistake, or maybe the thread breaks on the screw, and then they can't get the job finished in the time available. What happens in a GM plant, or a traditional GM plant, was that the car just goes down the line to the next person, and that job doesn't get finished properly, and then right at the end of the production line, there's quality control, whose job is to inspect the cars, and the ones that aren't going to be able to, aren't good enough quality, then get put in a parking lot to be fixed later. So they were finding a lot of cars coming off the production line that they weren't of sufficiently good quality to ship. What's different about a Toyota production line? What's different is you get some way along in your cell, and if you can't get your job done by around 2/3 of the way along, you can press a button or pull a cord called the and-on cord, and a jolly little tune plays, and a light goes on, and then a manager comes, and then the manager helps you. That was pretty revolutionary to the GM staff, that the manager would come and help you finish your job. And then, if you can't get the job done by the time the car is at the end of the cell, you pull the and-on cord again, a red light comes on, and the whole production line stops. It shuts down, and then you have to fix the problem right away. And then once you fix the problem and got the thing working, then you start the production line again, and then later on you reflect on how you can improve the system. Maybe you can ask for some better tools or change the way that you, the process for doing the job, and then you can get better at what you're doing. So the key idea here is that we're actually giving the workers the ability to build quality in, to make sure that they have the tools and the support to do their job right the first time, rather than letting bad product go further down the production line. And there's an exact analog to that process in software delivery. And the analog for that is test automation and continuous integration. The practice of making sure that we have automated tests that make sure we haven't done anything dumb, and checking in our changes regularly into Trunk in order to run those tests on a regular basis, and then if we find any problems, fix those problems straight away. So giving people the information and the tools they need to detect problems quickly and fix them straight away, rather than having a downstream phase to find problems and fix them. So this idea from the lean manufacturing movement of building quality in is really key. This is W. Edwards Deming, who is one of the people who helped revitalize Japanese industry after the Second World War, and he has this quote about quality: cease dependence on mass inspections to achieve quality, improve the process and build the quality into the product in the first place. And what this means in the context of software development, product development, is testers are not responsible for quality. Everyone is responsible for quality. And testing is not a phase we should be doing after dev complete. Testing is something we should be doing all the time. Testing your software and making sure it works should be part of the daily work of developers. Making sure that your software is meeting the appropriate performance requirements, that it's secure, that it's going to be available in production, that it's got good monitoring. That's part of the daily work of developers. And making sure that developers build those qualities that we want into the product, and giving them the tools and resources to invest in test automation and other kinds of validation to get that feedback as they're doing that work is probably the most important thing you can do to start on the path of Lean IT. So that's one recommendation, but there's no one-size-fits-all path to achieving higher performance. And so I just want to introduce one of the most important tools to get started in terms of Lean IT, which is value stream mapping. So value stream mapping was something that was first talked about by Mike Rother in his book, Learning to See. And what we do in value stream mapping is we look at a particular value stream. And there's many value streams in every enterprise, but the one that we care about typically from the point of view of software development is the product development value stream, which goes from a customer request for a new feature or for a bug fix through the process of designing and analyzing the new product or the new features we're going to add to a product, getting approval for that, doing release planning, going through development, showcasing, and then doing various kinds of testing before we go into production. And this is just an example. Every organization's value streams are different, and this is why it's important to get people together and analyze the flow of work. And what we're looking for is firstly to look at the total time it takes to go through, then look at the amount of that time that's actually spent doing work rather than waiting for other people to do things. So process time is the amount of the time, this PT number is the amount of the time that's spent actually doing work rather than waiting for things. If you had everyone together in a room that you needed to do a task, how long would it take to do it rather than how long it actually takes? And then percent complete and accurate, which is a measure of rework. So percent complete and accurate, percent CNA tells us if we get something from an upstream process, what percentage of the time do we have to send it back because it's not right? So just by getting together and spending a couple of days analyzing a particular value stream for one product or service within your company is a great way to get started, and then getting the people who can change these processes together to design a 2B value stream map of how we want the value stream for this product or service to look in 6 to 9 months is the next part of that process. There's a great book if you want to know more about value stream mapping by Karen Martin with Mike Osterling. This is a great resource if you want to learn more about how to do it. But it's a pretty simple exercise that only needs to take a couple of days. The hardest bit is getting the key stakeholders in the room to actually analyze the value stream map. So I just want to end with a summary of what I've talked about today. Firstly, Going faster and achieving high levels of quality stability is not a zero-sum game. What lean manufacturing teaches us is that we can get better at all of these things. We can increase quality and increase throughput and reduce cost by constantly working to improve our processes. In order to achieve high performance, we want to create higher levels of information flow within our organization, and the way to do that is to change our culture. I really recommend listening to that NUMI podcast because it talks about improving culture and how to do that. In order to get started, a great way to kick things off is to gather all the stakeholders in a particular value stream for a product or service that could do with some improvement, analyze flow, and identify those opportunities for improvement. And then finally, one of the key principles that should guide us is working to build quality in at the source, make sure that we find problems that are going to impact our services at the source by having test automation and performing integration continuously for our products and services, and running test automation at least daily as part of the daily work of developers. That's obviously a very quick whistle-stop tour. If you want to know more, you can get a copy of this presentation by emailing Jez Humble at sendyourslides.com with the subject DevOps. You'll get an excerpt from my latest book, Lean Enterprise, a preview of my continuous delivery workshop, some discount codes. Just email Jez Humble at sendyourslides.com with the subject DevOps. Thanks very much for your time today. I hope that's been a useful high-level introduction to the application of Lean to IT. If you have any questions, you can email me at jez@jezhumble.net. That will go up later. Thank you very much for your time.
All right. Well, Jez, thank you for facilitating our session today. For those of you listening, you will also be able to see Jez present at the Kata Summit, also known as KataCon 2, this February in Florida. To learn more, you can visit www.katasummit.com. As mentioned previously, today's webinar is being recorded, so look for an email following our time together for a link to the recording. Feel free to share this throughout your organization. So again, thank you, Jez, and thanks to each of you for participating in today's session. Goodbye.